Hello, my name is Danny, and this video is my Lewis alternate assignment for my chemistry course at MUN, Memorial University of Newfoundland in Canada. Chemical bonding is fundamental to chemistry. Lewis theory Lewis theory is a chemical bonding model. It can help us to predict and understand many chemical observations with simple dashes, dots, and chemical symbols. Lewis theory's strong point is in modeling covalent bonding. Covalent bonding involves sharing electrons. However, Lewis theory can also be used in ionic bonding. Ionic bonding involves transferring electrons from metals to nonmetals. Then the resultant ions are allowed to form a crystalline lattice composed of alternating cations and anions. Okay, so I'm going to show how to draw the Lewis structure for Na2S. Okay, so for people that saw my last video, I went over the periodic table, and so here again is my periodic table. So the first thing that we take is Na, which is sodium. So if we look on the periodic table, here, Na is on the left side of periodic table. That means it's a metal. And if we look at the sulfur, which is all the way over here, it's on the right side of the periodic table, so that's a non-metal. So when we combine a metal and a non-metal, we have what is called an ionic compound. Now, if we look at the sodium, again, if we look on the periodic table, the sodium is in group 1, so that means it has one valence electron. Now, if we look on the periodic table again, and we look at the sulfur, the sulfur is in group 16, so that means it has 6 valence electrons. One, two, three, 4, 5, 6. Now, Now, nonmetals always want to try to get an octet, which means have 8 electrons in their outer shell to become full. So it has only 6, so it needs 2 more. So the way that it works is it gets 1 from the sodium. So this valence electron from the sodium comes here. So that makes 7 valence electrons. So it still needs 1 more. So there's another sodium with the other valence electron, and it comes here, and that completes the octet for sulfur. Now, what we get for that is sulfur with the octet, and because sulfur gained electrons, it becomes an ion, and the symbol for ions is the brackets. And sulfur gained 2 electrons, so this charge becomes a 2-. And then here we have the sodium, and again, because it lost an electron, it becomes an ion. But here we had to make 2 sodiums. So it's basically, we have to have 2 of them there. And because the sodium lost an electron each time here, so it's kind of tricky when you're doing this, because the signs are kind of the opposite. So I kind of have to think about it just to make sure that I'm not making a mistake. So kind of like the way that I think of it is that if it's electrons are negative, so so if it's losing an electron, it's kind of gaining 1. Okay? And so we have to write that out in the formal way. And the formal way would be, we have 2 of these, 2 sodiums. So we have 2 Na plus, and then we have the sulfur ion. And that's the Lewis structure for Na2S. Now, we want to do another example. So our next example so we want to draw the Lewis structure of NaCl, which is table salt, sodium chloride. So again, we go through the same process. So if we look at our periodic table, we look for the sodium, which is here on the periodic table. So because it's on the left side, it's a metal. And we look at the chloride, which is on the right side. That's a non-metal. And so when we have a metal combining with a non-metal, again, it's in ionic compound. Okay, so if we check the periodic table, we look at the sodium, which is here, and it's in group 1. So that means it has 1 valence electron. Now, if we look at the periodic table and we look at chlorine, chlorine is in group 17, so chlorine has seven valence electrons. 1, 2, 3, 4, 5, 6, 7. So again, nonmetals want to try to have an octet. So nonmetals want to try to have 8 electrons so that their shell can become full. So here, in order to do that, the sodium valence electron has to transfer over, hence the word transfer, over to here to give chlorine its octet. So by doing so, when sodium, because sodium lost an electron, it becomes an ion. And again, you gotta be careful. I have to be careful when I think about this. So the electrons are negative. So if sodium loses an electron, it gets a +1. It's kind of like it becomes that much more positive. And then here we see that chlorine now has an octet. So that's 1, 2, 3, 4. Well, the way that I like to draw these, and I think it's kind of important because sometimes I see people who draw in the electrons, and I get frustrated because I don't think and I don't want people to pick up bad habits. I like the proper way I'm quite sure, to put the electron dots in are like this: 1, 2, 3, 4, 5, 6, 7, 8. So now chlorine has its octet, and because chlorine has gain electron, it becomes an ion, hence the brackets. And again, you have to be careful about the way you think about this. So electrons are negative. Electrons are negative. So electrons are negative. So when chlorine gains an electron, it becomes that much more negative by 1. Right? And my notation is +1 and -1, but you don't even really have to put that 1 in there. And you don't have to put that 1 in there either. So that's a Lewis structure for NaCl. So the resulting crystalline lattice looks something like this. And here we can see that, hopefully you guys can see it properly. So for those who are very new to chemistry, kind of like a crystalline lattice in general means that there's an orderly pattern of whether it's atoms or molecules or ions, and this orderly pattern of those, there's a repetition, right? So here, if you can see here you can see my drawing where you have all the chlorines here in that orderly fashion, right? And then you have like all the sodiums here, like in this orderly fashion, right? So that's the crystalline lattice for NaCl. And maybe I'll just keep that up for another second. Okay. So when the ionic compound NaCl is formed from its elements, we get this reaction. And this is the reaction. So like I said, when the ionic compound NaCl is formed from its elements, we get this reaction. According to sodium's first ionization energy and chlorine's electron affinity, the reaction should be endothermic. The reaction is exothermic due to the lattice energy. So here, as you can see, lattice energy, the energy that occurs when forming a crystalline lattice of alternating anions and cations from the gaseous ions. When the lattice forms, energy is emitted as heat, making the reaction exothermic. And here, as you can see again, are lattice energy trends. So lattice energies get increasingly exothermic as the ionic charges increase, and also lattice energies get decreasingly exothermic as ionic radius increases. So that's about it. Thanks a lot for watching. Remember to press subscribe, press all notifications, and I'll see you next time. Bye.